All right, good morning, y'all. Unfortunately, I could not be at school today. I just have a couple of doctor's appointments that I tried to schedule all in one day, and so I'm going to be out the whole day. Everything's fine. Don't worry about that. It's just a couple of routine things that I gotta go for. So what we're going to do today is go over the same lesson that I would have gone over with you in class, but I've recorded this video. A couple of things. You should already have this double-sided paper on your desk titled Features of Quadratic Graphs. And also make sure that you have a calculator on your desk because you're going to need it right off the bat. A couple of things here. If I'm going to try to paste this video in the same way that I would have taught the lesson with y'all. Unfortunately, I can't answer any questions, obviously. But if you need to hear something again or you feel like you're getting behind, definitely ask the substitute to pause the video so that you can get caught up. I will post a link to this video in your Google Classroom. I will also post a scan of these notes in your Google Classroom. So if you need extra time, ask to pause the video. If not, just, it'll be there. Okay, so let's get started. What we've been doing in our quadratics units for the past 3 weeks, it seems like, is factoring quadratics. Now, we've talked about quadratics in two forms, standard form and factored form. Well, today we're going to introduce a third form. And to introduce that, what we're going to do first is look at the graphs, because each of the forms that we've talked about tell you something interesting about the graph, among other things, okay? What we're going to do first is start with this function right here. F of x equals x squared plus 2x minus 3. Now, don't really worry too much about that f of x equals part. That's just how we say, hey, the function is all that. You can think of that as y equals all of that, okay? So what we're going to do is graph this guy by making a table. Now, to make a table by hand, what you'd have to do is draw a little t-chart, which we can go ahead and do. And then pick out some x values, then plug those x values back in to get some y values. But that's going to take a little bit of work. In fact, I don't want to waste a bunch of time doing that. I want to encourage you, anytime you need to graph a function, rely on your calculator because it will give you a bunch of great points and show you kind of how to connect the dots. So, what you're going to need to do first, make sure you have your calculator, that it's on, clear out any nonsense that's already in there, and hit the y equals button. I'm going to write these steps along the side here. Then, once you've hit the y equals button, type this function in, okay? Now, to get your x in, right here next to the green alpha button, right here next to the green alpha button is where you get your variable x. Then to get that exponent 2 for the x squared, there's a couple of different ways you could do that, but the easiest one is to hit this button right here, kind of diagonal from the 7. That'll automatically pop a 2 in for the exponent. So x squared plus 2x minus 3. So your first step, hit y equals. Your second step, type in the equation or the function. This little button right here next to the alpha is how you get your x variable. This button down here, diagonal from the 7, is how you get your exponent 2 in. Then we're going to go to a table that's already made for us by hitting second and then graph. So we're going to hit the second button and then the graph button. The nice thing about this is it has made a full and complete table for us with all the x and y values that we could want. Now, the best way to do this is to look at the biggest negative number that we could fit on our graph, the biggest negative x value. So hit the up arrow. Now, depending on who's used your calculator last and whether or not they cleared it for you, it may have started somewhere else in the table, but you can just hit these up and down arrows to navigate around there. Okay? I'm going to hit up until I get to a value that I can't really plot. So like negative 5, 12, I couldn't fit that on the graph that's provided here. But negative 4, 5, I can fit. So let me go ahead and plot that. Negative 4, 5. And then negative 3, 0. Negative 2, negative 3. Notice I'm just copying the table. Think about how much time this is saving us also from having to do all of this by hand. And then, 312, I can't fit it. Okay, so write down all the points you can fit on your graph. Okay, think about how much time this just saved us. Instead of picking negative 4 and then somehow getting 5, and picking negative 3 and 0, I just got 7 beautiful points that I can plot. I want you to notice something interesting about these points. 5, 0, negative 3, negative 4, negative 3, 0, 5. The y values kind of repeated themselves. They went like that. And that's actually exactly how the graph goes too. So now, let's plot all of those points. Negative 4, 5. That means go from the origin to the left 4 and up 5. Negative 3, 0. Go to the left 3. And if the y-coordinate is 0, you don't go up or down any. Negative 2, negative 3. Negative 1, negative 4. 0, negative 3 means don't go left or right any and go down 3. Then I've got 1, 0 and 2, 5. Then we're going to have to connect these dots. Now, obviously, it's not going to be a straight line. And these types of graphs have kind of a smooth, curved U shape. If you need to see what that graph looks like, you can actually see it on your calculator first by just hitting the graph button. You can see that shape, so we're going to need to connect the dots and make it look sort of like that. It doesn't have to be perfect. I just do want to emphasize though, this is not a V shape, it's more of a U shape. I want to say that because when you get to Math 3, you will see a V-shaped graph at some point, usually at the beginning of Math 3. And it's easy to get the two confused. So this is the shape of your graph. By the way, in case you remember back from Math 1 when you first saw this type of graph, it is called a parabola. A parabola. Now, what we're going to do now that we have sketched a graph of this is talk about a bunch of the key features of these graphs. Now, we've already talked about key features of just functions in general, meaning domain, range, increasing, decreasing, positive, negative, x-intercepts, and y-intercept. But there are two more that are unique to quadratics that are going to lead into our next topic in quadratics. So first, let's just remind ourselves of all of those other key features that we've already talked about. So, the domain of a function is all of the x values for which a function is defined, and you report them from the leftmost x value to the rightmost x value. Now, the nice thing about the domain for quadratics is it's always just all real numbers. You might also see all real numbers abbreviated ARN, or with this fancy little double struck R. It's like an R with an extra line through it. The domain for a quadratic is always all real numbers. Okay? The basic reason there is, domain just tells you what numbers you can plug in. And for all the things that, all these quadratics, you're just squaring numbers. And you can always square whatever number you want. So the domain's all real numbers. Don't worry about it. Okay, the range is not always all real numbers. For the range, it's all y values that can possibly be output by the function, reported from the lowest y value up to the highest y value. Okay? So look back at this graph, and if you don't have it already sketched down, maybe just take a minute, sketch it. We've got to look at the lowest point of that graph, if there is one, to the highest point on that graph, if there is one. Starting at the lowest end, do you agree that the lowest point is right here? What is the y value of that lowest point? It's -4. So the lowest point on this graph goes as low as -4. What about the highest? Well, there is no highest. Both of these ends of the parabola actually open up. So the graph doesn't stop going up at all, forever. Okay? So, how we write this whenever there's just a lowest but not a highest is like this. There's two ways. The first way, you would just say y is greater than or equal to -4. That is called set notation, where you have greater than or less than signs. The other way is interval notation, and it's written like this: -4, infinity. Put a bracket around the -4 and a parentheses around the infinity. The reason we do it like that is we say the lowest value to the highest value. The lowest value is -4. The highest value, there is none. So we just say to infinity. Okay, increasing and decreasing. You report these by reading your graph from left to right. Okay? It is the interval of x values for which, as the x value increases, meaning moving from the left to the right, the y value also increases. So, looking at this, the parabola will always be increasing and decreasing for exactly half of what you see. Okay? So starting at the leftmost value, I hope you agree that as I move right, I'm also going down, up until I hit this turning point right here. This section of the graph represents my decreasing. Then, this section of my graph represents my increasing. Keep in mind that because this graph extends in both directions, upward forever, starting on the left side, there actually is no starting point where it's decreasing. It just starts decreasing from forever. It's a weird way to say that. Okay? And then it hits that turning point and then starts increasing for forever. So, let's start with the increasing portion. It turns and starts increasing when x is -1, and then continues to increase for forever. So how we write that is all x values greater than -1, or -1, infinity. Notice I didn't put the or equal to sign, meaning I didn't put this bracket here, because technically at -1 it's not increasing or decreasing. It's just this weird math thing. We don't want to say it's increasing or decreasing because when x is -1, that's when the graph turns. Okay? Decreasing is basically all the rest of the domain. Reported from left to right, it's the interval of x values for which as x increases, meaning moves right, the y value decreases, meaning it's moving down. That's this first section of the graph. It is decreasing whenever x is -6 and -5 and -4 and -3 and -2, all the way up until it hits -1. Now this one's a little bit weirder to write, at least in interval notation. Set notation is kind of easy. X is less than -1. Interval notation, we got to be careful here. Because it's just less than -1, there is no smallest or leftmost x value. So this is going to be written like this: -∞, comma, -1. You put the leftmost x value, if there is one, then the rightmost x value. There is no leftmost x value, so it's just -∞. By the way, if you're having any trouble drawing the infinity symbol, it's just a sideways 8, so you can like turn your paper sideways, or you can just draw two little circles. Okay? And I do want to reassure you that we're not going to spend a whole bunch of time on the domain range, increasing, decreasing, positive, and negative stuff. So if this is throwing you off, don't worry too much about it. Okay. Positive and negative. Positive, again, we report from left to right. It's just what set or sets of x values where the y values are positive, meaning it's above the x-axis. Negative, below the x-axis. I think it might be easier if we start with negative first. So for what x values are the y values negative? Well, we see this little curve right here beneath the x-axis. So it's going to be all of our y values, all of our x values between -3 and +1. I also think it might be a little bit easier to write this in interval notation with the parentheses first. So going back down here, the negative part would be -3, comma, 1. That's how you write that in interval notation. Now it looks a lot like a coordinate, but it's actually not. It's just the way we write it. Okay? This means all x values between -3 and 1. Now in set notation, we have to write it like this: -3 less than x less than 1. It still means all x values between -3 and 1. It's just a different way of writing it. Now, the positive part, kind of weird here, because there are two sections of this graph that are positive. It's positive whenever x is less than -3, to the left of -3, right? All of this is positive, and it'll continue being positive forever. But also, it'll be positive for all x values above 1 forever. So there's two positive pieces here. Now, whenever there's two sections of a graph for which one of these key features is applicable, it's a lot easier to write it in interval notation. How we write it? First, we just write this section: all x values less than -3. So, -∞, comma, -3. Then we write the second part, which is 1 to infinity. And then we just put this u between them. Now, in set notation, all you have to do is say x is less than -3 or x is greater than 1. Those are the two sections for which the graph is positive. Now, if these four, increasing, decreasing, positive, and negative, are throwing you off, don't check out, don't worry too much, because again, those are things we've already talked about. If you need to go back to your notes from there, that's fine, but we're not about to start doing a whole bunch of that again. Okay? Your x-intercepts, you just say the x value of the coordinate or coordinates where your graph crosses the x-axis. You don't need to report the y value, because if it's an x-intercept where it crosses the x-axis, the y value is going to be 0. Okay? So, I hope you agree that this and this are both x-intercepts. This is an x-intercept, and this is an x-intercept. So all I need to do is say the x values. Well, it crosses at -3 and at +1. So that's it. Those are my x-intercepts. And all I need to say is x equals -3, 1. You could also say x equals -3, x equals 1, but it doesn't matter. You also sometimes will see it with this little brace around there. I really don't know why math people tend to do that. I think it's just to say, hey, it's a list of numbers. I don't know. And the last key feature that we've talked about is the y-intercept. Now notice this is not plural. There's one y-intercept. The y value of the coordinate where the graph crosses the y-axis. Now, we say the y value only because if it's a y-intercept, the x will be 0. For any function, there will only be one y-intercept if there is one at all. If you remember a little while back, we talked about what is and is not a function. Well, if there's two y-intercepts, it fails the vertical line test. That's something for another day, but that's the y-intercept right here because it crosses the y-axis. So the y-intercept is -3. So all I need to say is y equals -3. Take a minute, catch up on copying any of this down if you need to. Okay, so obviously you see that there are two more spots here, and therefore two new key features. Now, we did also talk about minima and maxima, the highest and lowest points, and what we're doing here kind of plays off of that. So, the first new key feature that's really only, it's applicable to others, but really applicable to quadratics, is called the axis of symmetry. The axis of symmetry. The axis of symmetry is the vertical line across which the graph is a mirror image of itself. Let's see. Let's find a scrap piece of paper real quick. This will work. Okay, so lines of symmetry, in case you aren't too confident, here's what a line of symmetry is. Let's say I drew this heart. The line of symmetry for this heart would just be this line right here. Because I could take that heart and fold it onto itself. Okay, and it would perfectly overlap. Same thing here with this smiley face. Well, I drew a little bit crooked, but I could fold it onto itself and it would perfectly line up. Now, lines of symmetry aren't always just a vertical line. Like for this fish, it has a line of symmetry this way. Okay, where I could take the image and fold it on top of itself. Okay, parabolas will all have one axis of symmetry, a vertical line. Now let me maybe get a different color here so I can distinguish. The axis of symmetry is this vertical line. That is the vertical line across which I could take my parabola and fold it. Okay? So, your axis of symmetry is reported as an equation. And it's just x equals whatever this number is. Basically, whatever the x value is where it crosses. So here, the axis of symmetry is just x equals 1. Again, the axis of symmetry is x equals 1. Or excuse me, x equals -1. Because it goes through there at -1. The axis of symmetry is x equals -1. Okay. And I hope at the beginning of this, I kind of mentioned that the y values kind of repeat themselves, and you'll see they're symmetric after -1. From -1, as the x value, the y values go from -3 to 0 to 5, and in the other direction, -3 to 0 to 5. Just another example of the symmetry. The other key feature for quadratics is called a vertex. All right? A vertex is just the turning point for a parabola. The turning point for a parabola. Basically, if the parabola was going down, where it starts going up. Or if it was going up, where it starts going down. Okay? The vertex for our parabola is this point right here. And the vertex, the coordinate of that is -1, -4. Okay? And so that's the vertex. You just report the coordinate. -1, -4. So let me zoom that out just so you can catch all that. Again, the axis of symmetry is -1. The vertex is the coordinate -1, -4. You may notice the axis of symmetry, x equals -1, is the same x-coordinate for your vertex. That'll always be true. All right, looking at the top of the right half of your paper. So far, we've talked about quadratics in two forms, standard form and factored form. And we factored the standard form quadratic expressions to translate them from standard to factored form. Now, I mentioned this a little bit ago, but coincidentally, the factors tell us one special thing about the graph, the location of the x-intercepts. Now, we're mostly pretty much done factoring for the next little bit, but let's factor this quadratic, ignoring the y equals part. This x squared plus 2x minus 3, that's the function we started with, that's the one we've been graphing, that we've been talking about. Factoring this, we're just looking for things that multiply to -3, but also add to +2. The answers are 3 and -1. So x plus 3, x minus 1. And then, for it to be a function, you would just say y equals. Notice that these two things don't look the same, but they do represent the exact same quadratic graph. Okay? Now, compare these factors to your x-intercepts. Do you notice how the x-intercepts, let's see if I can get both of these on the screen at once. Do you notice how the x-intercepts are -3 and +1, but the factors are 3 and -1? The weird thing about the x-intercepts is that whatever the factors are, the x-intercepts are the opposite numbers. That'll always be true. Okay. Now, the third form of quadratics, as you can see right here, is called vertex form. When quadratic functions are written in this form, the location of the vertex is explicitly written. So just like here, you can kind of figure out what the x-intercepts are. With vertex form, you can figure out where the vertex is like that, okay? In fact, you could pretty much sketch the entire graph without needing to make a table. Vertex form quadratic equations take this appearance. Y equals, let me zoom in on that, some number times x minus another number in parentheses squared, plus or minus another number. This could be x plus or minus some number, plus or minus some number, okay? And each of these a, h, and k stand for a number. And they all do something to kind of change the shape of our graph. So, a is the leading coefficient. In other words, it's the number in front of the x squared. Okay? So the number in front of the x squared. It's also going to match that number in front of the parentheses. So let me just write that. Well, here, just to make life simple, there is no leading coefficient that's written, so it's just a 1. H is going to represent the x-coordinate of your vertex. And so, the x-coordinate of our vertex we said was -1. So for f of x, this is -1. K is going to be the y-coordinate of your vertex. From this graph, we already found the vertex. It was, or the y-coordinate was -4. So, vertex form takes these three numbers, or to find the vertex form, we're going to take these three numbers and put them in here. Now, y equals, if the first number is just 1, we don't actually have to write it. Then x. Now be really careful here. This is minus h. Minus -1. Just trust me on this, just go with me. It's going to be the opposite number. And then -4. That minus there kind of just says do the opposite of whatever this number was. Okay, let me actually write that in. So, from a standard form quadratic, this is the main idea. Actually, yeah, let's go. Let's keep going on. From a standard form quadratic, we can rewrite it into vertex form by finding the vertex with 2 steps, and we don't need to graph the function. So, all of these steps that we took at the very beginning, not necessary. It's pretty easy. So first, use this formula. X equals -b over 2a. -b over 2a. To find the x-coordinate of your vertex. Simplify that expression and then substitute it back in to find the y-coordinate. So when you're thinking, oh wait, what do I mean by b and a from -b over 2a? I mean the coefficients here. Remember quadratics in standard form are like ax squared plus bx plus c. So a is the coefficient in front of x squared, and b is the coefficient in front of x. And we don't need it here, but C is just this number. So we can find the x-coordinate by using this formula, find the y-coordinate by plugging whatever we get from this ugly fraction back in, and then we can write it in vertex form by just putting the numbers in where they go. Okay? So let's practice that. We've got two quadratics in standard form. We want to rewrite them in vertex form by finding the vertex. Your first step is to find the x-coordinate. It's pretty simple. All we need to do is say x equals negative b over 2a. I'm going to say negative b over 2a a lot of times during the rest of this video. Okay? So, what is b? It's 6. So, plug in the correct numbers, negative 6 over 2 times a, which is 1. Multiply that on the bottom to get negative 6 over 2, and then divide that to get negative 3. Now, to find the y-coordinate, all I need to do is take this negative 3 and substitute it in for the x's back up here. Okay? So, where I had y equals x squared, I'm going to say y equals negative 3 squared plus 6 times negative 3 plus 8. Now, you could totally do all that work by hand. Say negative 3 squared is positive 9, and then 6 times 3, negative 3 is negative 18, and then subtract and then add. But honestly, especially for some of these more complicated quadratics, you've got this calculator. Just carefully type it in. Negative 3 squared. Make sure you put a parentheses around that negative if you're going to square it. Plus 6 times negative 3 plus 8. That gives you negative 1. Step 3 is to just write the vertex and then the vertex equation, or the vertex form equation. The vertex and the equation. So, the vertex, we found the x-coordinate here, the y-coordinate there. The vertex is negative 3, negative 1. The equation is y equals x plus 3 squared minus 1. I want you to notice, again, we flip the sign of the first number when we stick it in parentheses. And honestly, I know that doesn't make a lot of sense, but if you didn't flip it, you would get your quadratic, and it would be 3 or actually 6 units in the wrong direction. Okay? This vertex is 3 to the left, and then down 1. If I had left this as x minus 3 squared, it would really enough be 3 to the right and then down 1. Okay? So this is your answer. Your vertex is negative 3, negative 1. Your equation is y equals x minus 3 squared plus 1. Let's try it again. Here, this one's just a little bit different. Same process, but I've got a 2 in front of it. Okay? So, first step is to find the x-coordinate with that x equals negative b over 2a formula. Here, b is -6. So be really careful there. -6 over 2 times a, which is 2. Another way to think of that negative b part is just the opposite of b. Here, b is the -6 in front of x. So if that says negative or -6x, this is a -6. Okay? So -6 is +6 over 2 times 2, which is 4. And 6 over 4, I mean, you could leave it as a fraction, but it's really not important here, is going to give you 1.5. Now, step 2, find the y-coordinate by plugging 1.5 in. Y equals 2 times 1.5 squared minus 6 times 1.5 plus 1. Now, y'all, I don't want to do that by hand. I hate squaring decimal values. I hate multiplying decimal values. It's gross and it's just tedious, and so I'm going to carefully type it into my calculator. Because you know what? This is a $100 piece of equipment. We deserve to use it. 2 times 1.5 squared. Notice that the number I'm plugging in for x, I just put parentheses around it, minus 6 times 1.5 plus 1. And you get negative 3.5. Okay? So step 3, almost done here, is to report the vertex and the equation. The vertex is 1.5, negative 3.5. And the equation of the function is y equals x minus 1.5 squared minus 3.5. Now, there's actually one more piece that we're missing here. I want to show you how you can check your work. Now, if you're at home and you have Desmos, you can type this into Desmos and this. But I'm just going to use my calculator. Let's go back to y equals and type in 2x squared minus 6x plus 1. I can look at that graph. Now, if I've done my work correctly, I could type in this and see the exact same graph. So go down to y2 and type in x minus 1.5 squared minus 3.5. When I look at my two graphs, I'm going to get this parabola and then almost the same parabola. You'll notice that the vertex is in the same place, but that second parabola is just a little bit like further out. The thing that we're missing here is a. If the value of a is there, 2, we need to just put it right here. Otherwise, we'll get the vertex in the same place, but that 2 just kind of makes the graph a little bit skinnier. When I put that 2 in, by squeezing it in there, I'm going to get the same graph. That graph is drawn, and you can see it's still working right there, but it doesn't show anything else, meaning the graph is completely perfectly on top of itself. Okay, I know that that was a lot. So what I want you to do is flip your paper over. On the back side of your paper, you have 8 quadratic equations that I want you to work on. You can show as little or as much work as you feel like you need to. Okay? And then I'm going to say pause this video, let it go for about 10 to 15 minutes, just as long as most people need. And again, if you're not done, but it's just time for the video to go, I'm going to post this video so that you can copy the rest of what you need. Okay? So, pause the video for about 15 minutes. Okay? Just work on finding the vertex and writing the equation in vertex form, just like we did here. Again, you don't have to write all of this down, show all of your work. You just have to find the vertex and the equation. Okay? Take about 15 minutes, and then whenever pretty much everybody's ready, go ahead and play this video. Okay, by now I hope everybody has gotten their 15 minutes of work in, and let's go over these. I'm going to go a little bit faster, showing a little bit less work on these just because this is practice and I don't think we need to beat a dead horse. So first, the x-coordinate. For the first one. Negative b, that would be negative 10, over 2a, that's 2 times 1. That's going to be negative 10 over 2, which is negative 5. Then, I'm going to plug all of that back in, or negative 5 back in for all of that. So negative 5 squared plus 10 times negative 5 plus 24. That gives me negative 1. My vertex is negative 5, negative 1. The equation is y equals x plus 5 squared minus 1. There is no number that's really necessary to write in front of the parentheses here, just because the a value, the leading coefficient, was 1. Your second example, x equals negative b over 2a. That would be negative negative 4 over 2 times 1. Negative negative 4 is just 4 over 2, which gives me 2. Okay? The y-coordinate, just plug 2 back into all of this. So, 2 squared minus 4 times 2 minus 12. You get negative 16. So your vertex is the coordinate 2, negative 16. And the vertex form equation is y equals x minus 2 squared minus 16. Notice again, I switched the sign on the x-coordinate when I put it in parentheses there. Again, you can check your work by typing this equation in and this equation in, and you should see two of the same graph. Really just one graph, because it's going to be right on top of itself. Let's keep on working. X squared plus 3x minus 10. The x-coordinate, negative b over 2a. I'm going to say that a couple more times today. Let's see. B is 3. So negative 3 over 2 times a, which is 1. That gives me negative 3 over 2, which is negative 1.5. To get the y-coordinate, I'm going to plug negative 1.5 in through here. So, negative 1.5 squared plus 3 times negative 1.5 minus 10. That gives me negative 12.25. So your vertex is negative 1.5, negative 12.25. The equation is y equals, parentheses, x plus 1.5 squared minus 12.25. Fourth example, x equals negative 5 over 2 times 1. That gives me positive 5 over 2, which is 2.5. To find the y-coordinate, just plug 2.5 in. So let's see, 2.5 squared minus 5 times 2.5 plus 14. That gives me 7.75. The vertex is 2.5, 7.75. The equation is y equals x minus 2.5 squared plus 7.75. Four more. All of these have a number in front of x squared, a leading coefficient, other than 1. So we're just going to have to kind of remember to throw those back into our equation at the end. X equals negative b over 2a. Here, b is 4. So negative 4 over 2 times a, which here is 2. Now negative 4 over 2 times 2 is just negative 4 over 4, which is negative 1. The y-coordinate, just plug negative 1 in. So 2 times negative 1 squared plus 4 times negative 1 plus 1. Just double checking that I didn't make a typo. Okay, cool. And hey, the y-coordinate is negative 1. So here, our vertex is the coordinate negative 1, negative 1. And the equation is y equals 2x plus 1 squared minus 1. Again, notice how I flipped the x-coordinate, switched the sign on it. Also, I had to just put that 2 back in up here. Otherwise, this graph without the 2 would not be the exact same. Okay, 3 more. X equals negative b over 2a, which is negative 6 over 2 times 3, which is negative 6 over 6, which is negative 1. Negative 1 again. Y equals, plug a negative 1 in for all of that. Let's see, 3 times negative 1 squared plus 6 times negative 1 minus 2. The y value is negative 5. So my vertex is negative 1, negative 5. The equation is y equals 3 times x plus 1 squared minus 5. Two more. To find the x-coordinate, we use that negative b over 2a. Here, negative b is negative 5 over 2a, where a is 2. This gives me negative 5 over 4, which is negative 1 1/4. Plug that back in, definitely by using your calculator. 2 times negative 1.25 squared plus 5 times negative 1.25. Oops, and I made a typo there. That's plus 5 times negative 1.25. So type that in carefully. Minus 1. And you get negative 4.125. Your vertex is negative 1.25, negative 4.125. That's negative 1 1/4 and negative 4 1/8. All right, is that? That's an 8. Yeah, that's an 8. And your equation, y equals 2 parentheses x plus 1.25 squared minus 4.125. That's just beautiful, isn't it? One more. 5x squared plus 4x minus 8. So x equals negative b over 2a. Now b is 4, so that's negative 4 over 2 times a is 5. That's negative 4 over 10, which is negative 0.4, or negative 0.4. Plug that in to get your y-coordinate of your vertex. Maybe it'll be a little bit prettier. Maybe not. 5 times negative 0.4 squared. Now one thing, that 0 in your calculator is not actually all that important. So negative 0.4 is the same thing as just negative 0.4. Yeah. Okay, so 5 times negative 0.4 squared plus 4 times negative 0.4 minus 8 gives me negative 8.8. So my vertex is negative 0.4 comma negative 8.8. So my equation is y equals that 5 parentheses x plus 0.4 squared minus 8.8. I just have this weird habit of putting the 0 in front of the decimal. I think it's just because, for me, if I don't see the 0 in front of it, I kind of sometimes just like space out and don't even see the decimal, and then I mess up the example. Okay, take a minute. If you need to rewind any part of this video, ask your substitute to do so, or wait until you get home. I want you to get out a separate sheet of paper. So go and grab a sheet of paper. Remember, there's some on the bookshelf in the back of the classroom. And what I'd like for you to do is title that Exit Ticket. And what I want you to do is the exact same process we've been doing, okay? With 2 more equations. You can keep your notes out. You can use whatever you need to. Just don't cheat off of each other, okay? And if you're not 100% sure of if you're doing it right or wrong, show as much work as you can, because I like giving partial credit, okay? It just shows me what you do know and then where we get left off. So put your name on here. You can put today's date. And let's see. Find the vertex and then write in vertex form. The process we've been doing, these 2. Make sure I don't accidentally give you. So identify the vertex and then write that in vertex form. And then same thing here. Okay. Go ahead and take a couple minutes, write those in vertex form, find the vertex, write them in vertex form. Whenever you finish, make sure your name is on this, and please put it into the tray up front, at the front of the classroom, by the door, just like you're used to. Okay? I will try to grade those real quick whenever I get back on Friday, tomorrow, so that we can go over these at the beginning of your class. Okay? If you finish, now I don't know how much time, I know this is 1 hour into the video, and I know I said pause it for about 15 minutes to get started. If you have enough time, you are welcome to grab a Chromebook and work on any of your Delta Math. Just don't forget that your Delta Math is due Saturday at midnight. Okay? You did not have a choice board this week because Wednesday was Veterans Day. That's a state federal holiday. Okay? I appreciate that y'all have paid attention, followed along, worked hard. I hope that your substitute leaves me great notes about each and every one of you because I know you're all great people. And I look forward to seeing you tomorrow. If you need to continue working on this, just pause the video now. Otherwise, I'm going to go ahead and sign off. Thank you so much for watching. If you have any questions, hang on to them for tomorrow and we'll talk about it. Have a great day. Bye.